Hello friend, welcome to the course Multivariate Procedure with R. In this lecture, we are going to talk about a new topic, that is scaling of data. What is scaling of data? When we are trying to deal with multivariate procedures, this means we are going to have more than one random variables. And we are going to collect the observations on those random variables. These random variables may have the same units in which the observation have been measured, or they may have different units. For example, in case if I suppose I take three variables: weight of human being, weight of vegetable, and say weight of some students, right? Now all these three units, they can be measured in the same units, kilogram. Similarly, if I say the length of a electric wire, length of a road, and say length of a room, they all can be measured in meters. So they will have the same units. But suppose if I take three different variables like as height, age, and weight. So height is going to be measured in, say, for example, centimeters, weight in kilograms, and hemoglobin level has its own units in terms of levels. So now in such cases, sometimes it is needed that all the data should have the same units. But now once the random variable have been decided, which are going to affect the process, you cannot change them. So the next option is, given that data set, can we make them unit free? For example, height, weight, and age. They will be transformed in such a way such that height, weight, and age will have no units. When they have no units, that means their values can be compared. And this is the requirement in several statistical procedures. Yeah, I agree that if you try to transform the original data set, the statistical conclusions based on any statistical procedure, they may or they may not change. But that is what you have to see when you try to use such a scaling of the data, or you employ any scaling procedure to normalize your data. So now another thing is that sometime, for example, you have seen that in many probability distributions, we try to assume that their mean is zero. For example, many times we say that that the random sample has been observed from a normal population with mean zero and variance sigma square. Now, suppose in a real life the mean is not zero, then how are you going to make sure that the mean of those random observations is zero, in the sense that they have been obtained from a population whose mean is zero? So these type of scaling procedures and normalizing procedures are used in statistics, and in different multivariate procedures, sometimes they are needed. For example, if you remember, when we did the Chernoff phases, then there was a condition that the data has to be normalized. Similarly, another multivariate analysis procedure with that we are going to handle, either you will have this option that you can use them by standardizing the data or scaling the data, or use the original observations, and their outcomes may or may change. But this is the need of the experimenter which will decide also that whether it makes sense to scale the data or not. But my role here is only one: to make you explain or to make you understand that how are we going to do the scaling and normalization of the data, so that in case if you need, you can do it. If you don't need, you need not to do it. So let us try to begin this topic, and let us try to understand how we can scale or normalize the data in different situations, in different setups. Okay, so now we are going to talk about three topics: centering, scaling, and Z scores in this lecture. Well, Z scores is normalizing, right? So why this scaling is needed? So many times the data is collected on certain random variables, and these data are collected on some random variable which have some measurement units. For example, if the random variable is height, then it is measured in centimeters. If the random variable is weight, this is measured in kilograms, etc. And suppose we want to make these observations unit free. So for that we use the scaling of the data. This concept will make the observation unit free. So scaling is a technique for comparing data that is not measured in the same way, but different variables have been measured in different way, different units, right? So the scaling procedure or the standardization procedure, they transform the data so that the new data will have a mean 0 and a standard deviation of 1, right? And this type of standardization, when we are trying to mean 0 and standard deviation 1, this is also called as z-score. Right. If you try to see, you had done z-test in which you had taken x bar minus mu upon sigma by root n. This is statistics. So in this case, what we have done actually, we have the data x1, x2, xn, and we had transformed the data as a xi minus mu by sigma. Right. So this is called actually here as a z-score. And if you try to do it, then x1, x2, xn may, if they have normal mu sigma square, then z1, z2, zn, they will have normal 0, 1 distribution, right? So this is z-scores are obtained by here like this, means x minus x bar upon standard deviation, right? Some other procedure where we want to make only the mean to be 0, then they are obtained by x minus x bar. Of this observation, the mean is going to be 0. Right, means if you try to take x1, x2, xn and try to transform them x1 minus x bar, x2 minus x bar, and here xn minus x bar, then these observation, they may have some non-zero mean, but they will have mean 0. Right. And similarly, the third procedure, which is xi upon 1 upon n, square root of summation of sum of squares of the observations. This is another technique for the standardization of the data. So these are different types of procedure what we are going to discuss in the next couple of slides, and we will also demonstrate that how they can be used in the R software, right? So if you want to transform the data in any way, or you want to standardize the data, or you want to center the data, or you want to scale the data in our software, then we have a command here, scale, scale. And scale has different types of options. By using them, you can achieve what you want, like as only scaling, only centering, or both. Right, and this can be used on different types of object, on data vector, matrix, data frame, etc. So if you want to use this scale function, then the command here is scale, and after that you have to give here the x, which is a numeric matrix or a data vector or a data frame also. I will try to show you with the different examples. Then we have the option here, center, center, and this is a logical variable which takes value true or false. So this is, as the name suggests, centering. This is used for centering of the data. Centering means x minus mean, so that all the data is centered and the mean becomes 0. So this center is used to decide whether to subtract the mean values and scaling, and the default here is true. And then the centering is done using the root mean square. Root mean square is what I have explained you, 1 upon n summation xi square, this quantity. And if this is false, then no scaling is done. Similarly, there is another option here, is scale. This is also a logical variable here, true, and it decides that whether to divide the observation by the standard deviation while doing the scaling, and the default is the true, right? And if true is given, then the scaling is done by dividing the centered columns of x by their standard deviations. Well, I will try to show you, and right. and I will explain you how what procedures are being followed inside the R software, right? So the value of center actually determines how column centering is to be done, right? If a center is a numeric like vector with the length equal to the number of columns of x, then what happened? The each column of x has the corresponding value from center subtracted from it. And if center is given the value here true, then the centering is done by subtracting the columns mean of x from their corresponding columns. And in case if center is equal to here false, then no centering is done, right? And then yeah, means here this unavailable observation n is they are omitted. Similarly, the value of a scale determines how column scaling is done after centering. And if a scale is a numeric vector whose length is equal to the number of columns of x, then each column of x is divided by the corresponding value of the scale. And if the scale takes value true, then the scaling is done by dividing the centered columns of x by their standard deviation. And if center is true, then it happens. And in case if center is false, then no scale is done. And when center is true, then we use the root mean square to divide the values. So how it is going to be how it is going to be done? Let me try to take very simple example and I try to explain you. First way I try to show you on the slide, then I will try to show you on the R software also. So let me take a very simple example in a data vector. I just take 4 values 1, 2, 3, 4, which are stored in a data vector x. Suppose you try to find out its mean, it will come out to be 2.5. If you want to find out a standard deviation, it will come out to be 1.29, which is obtained by square root of variance of x, right? Now if you try to compute this quantity, x minus mean of x and square root of variance of x, right? So this I am writing here, x minus mean of x divided by square root of variance of x, then this value comes out to be here like this. So this is a standardization of the data or the scaling of the data. But now let me try to see the same thing if I want to obtain in the R software, how it is going to be obtained. So I try to take here the same data vector 1, 2, 3, 4 and I try to use here the command scale x. So this is going to give me the outcome here, see here x minus x bar divided by standard deviation. And you can see here, this is how the outcome will look like. You can see here minus 1.16, minus 0.38, plus 0.38 and 1.16, right? So you have to just remember minus 1.16, 0.38 and plus there with their positive sign. And what you have obtained here earlier, 1.16, 0.38 with minus sign and the same quantities with the plus sign. So you can see here, this is the same result what we had obtained by manual computation, but now it has been obtained directly by this scale function, right? And then it is trying to give you here the scaled. That means it is trying to inform you that it is centered. So the arithmetic mean here is 2.5, which you had obtained here earlier. And then it is giving you the scale value, which is here 1.29, which is the standard deviation which you had obtained here. You can see here 1.29 and here also 1.29. Now in case if you try to use here the complete command, which is advisable actually, then you must use the scale and center, both the option which can be written here by here, scale of x, scale is equal to true and center is equal to true. Yes, you have to be watchful and careful here that scale is also the R command and scale is also a parameter to be given inside the parenthesis, right? And similarly, if you use only here scale x, scale is equal to true, then both this option, both these commands will give you the same outcome like x minus x bar divided by SD, right? So now you can see here, this is the outcome. I can show you here, so that this is my here data whose mean is 2.5 and variance is 1.29, and when I try to scale them by x minus x bar upon SD, this comes out to be here like this. And when I try to use here this scale function, so you can see here this function is matching with this function, this is matching with this is matching with this, and this is matching with this, right? And in case if you try to use here scale is equal to true, center is equal to true, or only scale is equal to true, you can see here that these values are the same, right? But my advice to you all is that to use this one. Both scale and center options are clearly mentioned here, right? So let me try to first show you these things on the R software also. So let me try to have this data set here. So now let me come to the R software and I try to give you here the data here x equal to like this. So x here is like this. And if you try to find out this command here, that where you are trying to write down here the square root of mean and variance of this thing. So let me try to execute it here. You can see here it is here like this. And on the other hand, if you try to use here the function here scale, you are getting here the same value, right? That you can see with this value, this value, this value, this value, and remaining the two values. And similarly, if you try to obtain here these two commands also here, then also you will get here the same value. For example, if I try to execute, you can see here this when you are trying to say scale is equal to true and center is equal to true, it is giving you here these values. And if you are using only scale is equal to true, then it is giving you the same values, right? So that is how you can see that it is not a very difficult thing. And when you will say be using different types of multivariate procedure, then there will be some option which is given to you that how are you going to, whether you want to scale the data or not. Now I try to use here one more option of this scale function, that scale is equal to false. So when you try to use here scale is equal to false, then it will only do the centering. That means x minus x bar. So now what will happen? The mean of all the observation will become 0. So if you try to see what I am doing, I take here the same data 1, 2, 3, 4. Its mean is 2.5. So if I try to subtract each of the data by 2.5, 1 minus 2.5, this will be here minus 1.5, right? 2 minus 2.5, this will be your here minus 0.5. Similarly here 3 minus 2.5, this is here 0.5, and 4 minus 2.5, this is here 1.5. So every observation has been subtracted by its mean. And the same operation can be done in the R software if I try to write down here scale x with an option that scale is equal to false. So you can see here this is my here data set. So this value, if you try to match, this is coming here. This value, it is coming here. Third value, it is coming here. And the fourth value, it is coming here. And what is here? This 2.5, this is here the mean which you have obtained here, right? And if you try to hit on the RS software also, it will here look like this. This is your here data vector. And with this, I am trying to obtain it manually, x minus mean of x. These values are obtained. And then I try to use here scale function. So you can see here this is matching with this is matching with this. Third value is matching with third value, and the fourth value is matching with the fourth value, right? So let me try to show you these things on the R software also, so that you can be confident, right? So if you try to see x is here like this, and if you want to find out here x minus mean of x, this is here like this. And if you want to use the scale function, it is giving you here the same value, right? So now you can be confident that it is working in the same way as I explained you on the slide. So let me take here this same data vector x equal to C1234, and I would like to use here another option, center is equal to false in the same data vector x using the same function here, same command scale. So if you try to use this scale on a data vector here x with the center is equal to f, that is false, then it gives you here this type of value. Every observation is divided by 1 over n minus 1 square root of sum of I goes from 1 to n xi square. That means you have to take the positive square root of the sum of squares of all the observation and divide them by the sample size minus 1. So if you try to see here in this case, I try to take here x equal to like this, then square root of sum of x into x divided by 3, which is here 4 minus 1, it comes out to be here 3.16, and if I try to divide x divided by this quantity, then it will come out to be here like this. These are the 4 values which we are going to obtain. And if I try to do the same thing in the R software also using the command here scale, then it is coming out to be here like the scale x enter is equal to false, and you are getting here the same values. So if you try to see here and try to match here, what are you going to get? The first value is matching with the first value here, the second value is matching with the here the second value, then third value here is matching with the here third value, and the fourth value here is matching with the fourth value here, right? And this quantity here scale, this is here matching with the square root of sum of x into x divided by 3, right? So you can see here that the same thing has been done here without any problem. So this is another type of scaling, and yeah, I would try to show you this on the R software also. So let me try to take here, right? My x is here already here like this, and if I try to say here like this, the scale function, it is giving me this thing, and if you try to use here the same command which you have written manually yourself, it will also give you the same value, right? So you can see here it is not difficult to do this. Okay, so now I have explained you these things over a data vector. Now I try to repeat the same operation over the data frame, because data frame will also play an important role when you try to do the multivariate statistics. So if I try to take here two data vectors, one is here x c1 2 3 4, and another I am taking here y as 10 20 30 40, so that it is easy to remember you that which data is corresponding to which variable. So the first variable is 1 2 3 4, and second is 10 20 30 40. Now I try to create the data frame using x and y using the command data dot frame like this, and we store it in a variable dfxy. So now you can see here this is the data frame that we have obtained, right? Now I try to use here the same command which I have used earlier and try to see what happens. You will see the similar outcome will come, but now in a different way. All the scaling is done for each and every variable. So if you try to use here similar to scale of x, if you try to use command here scale of dfxy, then it will give you the value of x minus x bar divided by st, that is standard deviation for every observation in each of the variable. So you can see here this is the value for the first variable x, these are the values for the second variable, and they are now normalized. So these are actually the z scores, and you can see here this is here giving you the values of the means of the x and y which have been used in the centering or say scaling, right? That is x minus x bar. For x the mean is 2.5, and for y the mean is 25.0, and similarly the standard deviations have for x and y, they have been obtained here like that. Now I have done it for using the command scale, but if you want you can also do it using writing your own command the way I have shown you earlier. Similarly, if you try to use the second command, that is scale, earlier we had used x and scale is equal to false. So now I'm using it over the data frame. So this is going to give us the centered value for each of the column. That means every observation for each of the variable will be centered by x minus its mean. So for the column, it will be every observation minus its column mean, right? So you can see here, this is the centered observation for x, and these are the centered observation for y, and the sample means are obtained here 2.5 and 25. So for x, every observation is centered by x minus 2.5, and for y, every observation is centered by y minus 25. So you can see here this option is also working in the data frame also. Right. Similarly, if you try to use here the earlier command scale dfxy with the option there center is equal to false. So you can see here that it will give you the similar value that xi divided by 1 upon n minus 1 square root of sum of squares of all the observation for each column. So you can see here this is the standardized value which are obtained using this function, and these are the standardized value of y which are also obtained using this function column wise, and these are the a scale value which have been used in this data set, which are essentially the values of 1 over n minus 1 summation xi square, and it's the square root, and 1 over n minus 1 summation yi square, and it's the square root, right? So these are these values. So now you can see here, this is the screenshot of the same observation I explained you. So here I'm trying to create the data frame. Then I am using only scale dfxy, or you can also use scale is equal to true and center is equal to true, which I always recommend. And then I am using here the scale dfxy with the scale equal to false, and the next command is this center is equal to false. So these are its outcome, but I will try to show you on the R console also. So let me try to first create this data frame. So this is my here data frame, you can see. Now I'm trying to use here, say, scale of df xy. You can see here, these are the values, which are the same values which you can see here in the slides I have obtained here. Now I try to use here the next command, scale, with scale is equal to false option. So if you try to see here, it is here coming out to be here like this, where every column value have been subtracted by their column mean. And now if you try to use here another type of this scaling, then if you try to execute them, it is giving you here this value. So these are the same value which I have shown here on the screenshot also, and in the slide also. So you can be confident that these things are working. Now I try to repeat the same thing for a matrix, because you will see in multivariate analysis many times you have to give the data in the form of a matrix. So you have to be confident that these procedures are working over the matrix also. So let me try to create here a 3 by 2 matrix of the values 1, 2, 3, 4, 5, 6 using the command matrix n row equal to 3 and col equal to 2 and data is equal to 1 to 6, and I store this data into this matrix, say xm, right? Now I try to repeat the same thing what I have done earlier for the matrix data also. So first I try to use here scale xm, so it will give you here these values, which is here that x minus mean divided by standard deviation for each of the column, right? So this is for here the first column, this is here for the second column, right? And these are here the mean values, column means, and these are the standard deviation for each of the column, right? Similarly, if you try to use the earlier command for centering scale, then this matrix data xm, then scale is equal to false. That means every column will be subtracted by its by the arithmetic mean of the column means. So you will see here this type of outcome will come here, that this is the output for the first value and this is the output for the second column, and these are the means arithmetic mean of, or the column means of the data in the two columns, right? And if you try to use here the earlier command, that scale say xm center is equal to false, then using this command here, you can get here this data set. So these are the values for the values in the first column, and these are the values for the values in the second column, right? And the value of the denominator in the two columns is obtained here like this. Well, it has, these are very straightforward things, and you can see here this is how I have obtained. This is my here data, this is my here scale function, then I try to use here scale is equal to false, then I try to use here scale is equal to center is equal to false, right? So if I try to show you these things on the R console also, then you will feel more confident, right? So let me try to create here this matrix here first. So you can see here this is my here matrix, and if I decide to say here scale equal to here xm, you can see here like this, right? And if I try to give here this another command, so using this only scale function will essentially give you the credit score. So many times people will ask you, please standardize your data using the normal score or credit score. That means you have to simply operate the scale function. Now if you use here scale is equal to false, then it is doing only the centering. And if you try to use here center is equal to false, center false means only it has to be means no centering is required, only scaling is required, right? So if you see here, it will come here like this. Right, so you can see here it is not a very difficult thing to do, and now with this we come to an end to this lecture. And you can see here it was not a very difficult thing to do, but the main idea is that you are trying to transform the data in a particular way, right? And the need, whether you want to do only centering, only scaling, or only this dividing by the standard deviation, or this root mean square deviation, it depends on the statistical function which you want to use and what is the requirement of the data set. And when you are trying to do it, now the data is going to change its nature. So it is possible that the statistical conclusions may also change. So in my personal experience, the way I do is that whenever I'm trying to do with this statistical procedure, I try to do it twice. It takes only a couple of seconds or a couple of minutes only. And I try to get both the results, with standardizing and without standardizing. Usually they are different, but then I try to interpret them, that with which of the case the results are matching with the with the true values. That means what is happening in the real experiment. And then I try to take a logical discussion in consultation with the person who has collected the data and who has conducted the experiment, because they are the people who are going to tell me that, okay, if I try to do the centering, scaling, etc., is it really going to make any sense or not? Well, I'm not going into this discussion that whether you should use or not, but anyway, this is the requirement of the statistical procedure. So that is why I just covered it here, so that you are well aware of this scaling and normalization of the data, including the centering. So I would say that whatever we have done in the past, means we have done now lots of statistical procedures. Why don't you try to repeat all the things with the after scaling the data? You try to scale them, you try to standardize them, you try to center them, and then try to see what is happening. Definitely, it is going to take some time, but definitely, without practice, you cannot learn. So my advice to you in this lecture towards the end is that don't do anything new. Just try to take the earlier tools, whatever you have done, either that is mean, whether that is standard deviation or t-test or anything, and try to repeat those things, whatever you have done with the scale data. In some statistical function in the R software, there can be an option like scaling is equal to or scale is equal to true or false. But if that is not there, you can simply store the new data which is obtained from this scale function directly into a data vector or a matrix or a data frame, and then you can use them directly. So it's not difficult at all. So my request to you all is that please try to have a look, please try to exercise these concepts and make yourself learned and well aware with the statistical tool. And I will see you in the next lecture with a new topic on regression analysis. Till then, goodbye.